Today's video, we are going to learn about a topic called current density. And to understand what is the meaning of this topic and how we can relate this topic, we need to go back to the basics first. So I'm going to take some points for you. I'm going to explain few points for you for your understanding so that you can relate this topic. First thing, we know current. Okay, we already understand this topic in detail in our previous video also. So we know current I is equals to charge per unit time. Okay, so I will not cover too much in terms of current, but there is a word called density. What exactly you need to understand? When you are in grade 11, you learn about the word called density, and the first density what you learn, that is a rho mass divided by volume. Yes or no? You learn this thing? Mass divided by volume. This is the basic formula for the density. But guys, this is not the only thing that in particular volume, how much amount of mass we have. We have the different types on which you need to focus. First, just go back to the basics of the density again. Let's say you have a particular volume, okay, and in this particular volume how much quantity you have, this is called the density. I'll give you easy example, then it is easy for you to relate also. Let's say this is a classroom. Okay, in this classroom your volume remains the same. How? The length, the breadth and the height, all three remains the same. But let's say in case 1, you have 10 students in the class. 10 students. Okay, so can I say the density is equals to 10 students? Let's say the volume is 100. Okay, let's say volume is 100 meter cube and the number of students is 10. Fine, this is your density 1. Now in case 2, if I increase the number of students, because of volume, the size of the class size remains same. So let's say if the students, now we have a students 30 students in the class, then what will happen? Now we have a density 2 which is equals to 30 divided by 100 meter cube. You understand what is happening? We are increasing the mass, or we are increasing the number of students, or we are increasing the quantity. So on the quantity, density is directly proportional. Okay, now the second part in the density, what exactly you need to focus. In term 1 also you learn about the charge density. So in terms of charge density, you learn about 3 basics. First, you learn about the linear charge density. Okay, what is the meaning of this one? Linear charge density is lambda is equals to charge by length. That we are checking, or we are just trying to understand. Let's say this is the length, how much charge is on the length. Okay, you understand the length remains the same and we are finding how much quantity is there. Let's say in first case, if you have only 2 electrons, 1 and 2, so you can say 2 electrons per meter. Or I'll take another example which makes it easier for you to understand. Let's say the wire is 1 meter, wire length 1 meter. Okay, and you have 2 electrons. So what can we say? Lambda is equals to 2 charges per meter. Fine. If let's say now case number 2, this is your case number 1, case number 2, now you have 5 electrons, so you will say 5 electrons per meter. If you have 10 electrons, so you will say 10 electrons per meter. Yes or no? This is the density. In a similar way, you learn the second part, surface charge density. So what is the surface charge density? What you learned, sigma is equals to charge by area. Now instead of length, we are discussing about the area. And the third, what you learned, volumetric charge density. So in this, what you learn, rho is equals to charge per unit volume. So exactly you need to focus that we can compare in terms of volume, in terms of area, in terms of length. So what we are learning today, we are learning current density. We are learning about current density. So in the current density, where we are learning all these things, we are learning inside the wire, inside the wire. And what we are doing, we are not taking only a line. This is your line, but we are covering the whole area. What we are covering? Area. So what should be the formula? The formula should be J, that is a symbol, current divided by area. Is it fine? Now you are able to understand that which kind of density we are finding. We are finding surface density. We are finding surface density. Okay, that is the current density. Clear? Okay, now go back to the topic. So guys, this is our topic, current density. Now we understand, and just go through the definition. Okay, current density at a point in a conductor is defined. Okay, is defined as amount of current passing a given point per cross sectional area. So J is equals to I divided by A. Clear? Okay, so here I is your ampere, A is your meter square. So what is the unit you can say? Ampere divided by meter square. Fine guys? Okay. Now the second point. First point is finish. Now we need to understand about the direction. Okay. Let's go to the next page. New page. I need to add here so that you can understand. Okay. Now I'm going to cover point 2. Point 2, direction. Okay, the first point here, as we know, current. It is a scalar quantity. Scalar quantity. Second, what we have? We have an area. That is also a scalar quantity. Then how we can find out the direction? That should be the question in our mind. How? In that case, because the J, that is the major thing, that is the vector quantity, we need to solve for that. So in that case, we have a word called quantity, and these are of 3 different types. First, we have the scalar. Scalar means magnitude only. Magnitude only. Okay, vectors, which we have magnitude and directions. That should be a specific direction. Specific direction. And third is called tensor. Okay, I'll show you some example first, then you will understand what is the concept of tensor and the vector. Let's say guys, if I write B vector, so how I need to write it? B and B cap. What is the meaning of this statement? Just try to understand. This is your vector B. Vector B. This is the magnitude of vector B. Vector B. And what is this? This is called the B cap direction. But the interesting point, what you need to understand here, let's say this is a body and I'm applying a force. Okay, there is a vector B, let's say. So B vector. So the magnitude is B and the direction is B cap. Both are in same direction. Both are in same direction. Okay, now what you need to understand in terms of tensors, before going to explain, what exactly the tensor quantity is, you need to understand the example. Let's say A vector is equals to A n cap. See, if it is a vector quantity, then it should be A cap here. Just try to understand. Huh? A vector equals to A cap. This is the vector and this is for tensor. You need to keep this thing in your mind. Huh? I'm going to highlight this point. There is the n cap, here is A cap. This is the major difference. And n cap is the perpendicular direction. I'll show you how to solve this. Okay, I will show you. So before that, you need to understand what is tensor. Actually, they are scalar quantity, scalar, but we give them assign directions, assign direction. So they will behave like a vector. But guys, just remember their directions are always perpendicular. The directions are always perpendicular to the surface. I'll give you an example so that you can understand. Okay, let's say this is the area. This is a circle. Okay, so what should be the direction of n cap? It should be perpendicular to the surface. Here is n cap. Because let's say your table. Let's say this is your table. Okay, so this is the surface, na? This is the area. This is the area. So where should be the n cap? It should be the upward. Clear? Another example, because you should know the basics of all these things. Let's say your this is something bad. Okay, let's see. You prepare something like that. So what is this? Like your hand. So the area should be like this direction. Clear? Okay. So what we are learning here? We are learning about in terms of current density, okay, and how to solve this. Okay. Go back to the topic. Okay. We need to understand the direction. So we have a formula. I is equals to I, just we are rearranging. I is equals to integration j dot dA. Okay, so what is this? This is a vector, this is also a vector, and this is your dot product. So can I say j a cosine theta? As we know dot product, I'll write a formula for you. A vector dot b vector, which is equals to a b cos theta. And we have another one, a vector cross b vector, which is equals to a b sine of theta. Fine, guys? Okay, so what is the angle here? That should be the theta between j and a. So just check. Let's say in the wire, this is the wire. Okay, and try to understand. Let's say this is the particular area we are looking about. So the first thing, electrons are flowing like this. So we get the direction of j. And now what you need to understand, let's say if this is your area, then where is the n cap? The n cap is this direction. So I'm just going to change the color for you. So this is the direction of n cap and this is the direction of j cap. And so if both are in same direction, j cap, n cap, so can I say theta is equals to 0 degree? Yes or no? Because both are moving in the same direction. So if both are moving in the same direction, then cos 0 degree is equals to 1. Fine, guys. This is the major thing what you need to understand. So what is the angle between J and A is 0 because both are traveling in the same direction. Fine, guys? Okay. This part is for the enrichment, and if you actually want to study, you can just study from here, and there is a relationship between the how you can make a relationship between the drift velocity. Drift velocity, simple, in simple terms, you can just make a relation with the velocity, how current is flowing, and once the current is flowing, what should be the velocity, and how we can relate this velocity with the length and time. Length, time, okay. After that, the volume of the wire, number of electrons of the wire, and then we relate all these things with first with the current, and then we learn and we how to just make a relation with the current density. All 6 steps are here, and this is for enrichment, guys. If you want to study, I write all the steps in a very easy way so that you can understand and you can take the benefit. Okay, guys.